Well, hello everyone and welcome back to Adrian's Digital Basement. On today's video, we're going to be looking at something kind of unusual again. What we have here is a Pravetz 8D computer. It's an 8-bit microcomputer that was made in Bulgaria. And as far as I understand, this is a clone of the Oric Atmos, a machine I really know nothing about other than I think it's a 6502 CPU in there. This machine was given to me by a local collector and friend up in Seattle, and I know nothing about it. So in this video, I want to take it apart, play around with it, see if it works, and well, we'll kind of go from there. So without further ado, let's get right to it. The Pravetz 8D. I know very little about this computer, but when I was given the machine, I was told that it was possibly an Apple II clone. But I don't think that's actually the case looking at the keyboard layout on this machine. The keyboard actually seems really nice to type on, and compared to a lot of these Eastern European clone type machines, that's not always the case. And the entire case actually feels really nice and not cheap and nasty either. The spacebar on this thing does seem to be disconnected or broken. It does have a stabilizer. And you can get a look at the key switch. That seems to be a cherry key switch. Well, no wonder why this thing doesn't feel so bad. The keycaps themselves are interesting. I don't think they're double shot. I think they actually have paint inside the lettering, which is depressed, which is odd. Now, oddly with the spacebar, it doesn't really feel very nice to type on, and it seems to bind up on the computer case. I don't think this thing is used very much because the keycaps look extremely unworn, just ever so slightly dirty. But maybe I could just reposition the keyboard and that will clear the case and not have it bind up on the edge here. Notice the standard European style plug. We have a power switch, serial port, printer port, cassette, display, and television. Now when you look at the back though, it looks like there's actually no RF modulator installed, and we have DIN jacks for both the video and cassette, and it looks like the serial and parallel are just pin headers. On the bottom of the machine, everything looks pretty good. It's got rubber feet. It has 5 fasteners, which I've already taken out just so we can lift that cover off pretty easily in a moment. And we have a label describing what this machine is. Looks like we have a serial number of 329. I have to imagine the 100 is irrelevant. And a date code of 1988. We do see an internal speaker that seems to be just pressed up against the bottom of the case. There seems to be a momentary switch, maybe a reset button. And we do have an adjustable potentiometer, which almost certainly is going to be used for clock frequency adjustment, which probably has an effect on the color carrier for the video output. Now, I actually don't know if this machine has composite video output or RGB, hence the fact it has this 5-pin DIN. Maybe this does just have RGB. If we lift the cover, just unplug the keyboard, that's really clean. Internal power supply, voltage regulator, large piece of metal for the heatsink. There's our power switch. My assumption is this has to do with the keyboard, which seems to have a mechanical PCB. Since we know it has cherry switches, we don't want it to poke into those capacitors. And it's a good thing they put this here because you can see there's little divots in the cardboard, so that's doing its thing. Looks like we have a single voltage rail that comes out of here, so it's just going to be 5 volts, and yet 7805 almost certainly. And the motherboard on this is nice and clean. So we have 6522 from Rockwell. This is probably the CPU, a CM630P. Sound chip, that's an AY3-8912. These are probably the ROM chips for BASIC and whatever OS is on this thing. There's our internal speaker. This is probably a ULA or ASIC, probably designed to handle the video output. Also the memory interface, probably the cassette interface. I have a feeling the serial and parallel, they'll probably go right through the 6522 directly. As you notice, we have a mix of Western ICs along with probably Bulgarian ICs. Now, Bulgaria was never actually part of the Soviet Union. They were a close ally of the Soviet Union. So I think a lot of the Bulgarian computers, like the Pravetz stuff, got sold in the Soviet Union, but Bulgaria would have had access to Western ICs. And actually, I see some Japanese ICs on here, so Asian stuff as well, which would have made it easier to manufacture this stuff. I don't really recognize this logo, but maybe this is a Bulgarian company that made these ICs along with the RAM. As far as I'm aware, this is going to have 64K, but we'll look that up in a second. This is, well, I don't know what company this is, HCS CDI. Looks like we have a Motorola part there, National Semiconductor, Panasonic. Maybe that's a Signetics part, not too sure. Looks like the adjustable capacitor is underneath there, sticking through the bottom of the case, right next to the crystal oscillator, which is what, 12 megahertz? And then we do have another crystal right there. Can't really read that. Looks like a date code, 0887. And there's some writing on this side, but I can't quite make out what that speed is. So yeah, 2 crystal oscillators on this board. And from a date code perspective, 87. Although these RAM chips here, 48th week of 1988. So it kind of dates this machine and coincides with what we saw on the bottom from a 1988 perspective. The keyboard definitely has some fasteners that maybe we could shift it up slightly just to keep that space bar from binding. And with those fasteners loosened a little bit, looks like I can move this around. It looks like sliding it up to the top. These keys don't really bind, and the spacebar works now without binding up. Part of me wonders if this keyboard's been out of adjustment its entire existence. So whoever had this machine back in the day just put up with that binding spacebar, or maybe they just never used the keyboard. Yeah, even though these number keys look like they're very close to the edge, they actually are fine, and the spacebar works properly now. First, let's start with Pravetz, the manufacturer of this machine. It seems that they existed from around 1979 and really were there to make computers for Bulgaria. Looks like they started making large computers, but then they moved into making small machines like this, personal computers, with their first computer, which I don't think was largely mass-produced, the IMCO-1. And it looks like all of their 8-bit machines, excluding this, the 8D, were Apple II clones. And we can see here that their later Pravetz 82 machine, that would have been after the IMCO, was used in Russia in school classrooms. Now, the first machine, the IMCO-1, was running at 8 megahertz, just running a clone 6502, and it was just a direct, exact copy of the Apple II ROM. And then the 82, the machine that was first seen in that photograph, was actually a first mass-produced computer from Pravetz. And it had an optional 5¼ inch disk drives, Apple II compatible, obviously, based on that photograph that we saw there. It says here, a lot of the chips used were Bulgarian and Soviet substitute clones of the original chips from the Apple II. And the Pravetz 82 was relatively reliable, as most hardware problems are due to the widespread use of substandard quality IC sockets. There was a later 8M variant, which included CP/M compatibility, otherwise it was just an Apple II with CP/M. An 8A, which used the CM630. That's the clone CPU we have in this machine. Looks like it had 64K banking memory, which basically was a clone of the Apple IIe. And there was a later 8C, or streamlined version, aka Apple IIc, with 128K of RAM and less slots. And then the 8D Delta, that's like this machine we have here, 8-bit home computer, still a 6502, but it uses a VS6522 for I/O, uses a TV set instead of a computer monitor, and is not compatible with the Pravetz 82, of course not, because that was an Apple II, and this is a clone of the Oric Atmos home computer. It looked like Pravetz went on to make IBM PC compatibles as well, so that's their 16-bit line, all the way up to 286s, 36, and 486s. Pretty cool. I have to imagine in Bulgaria, it's probably relatively easy to get all of these machines, at least these 82s. Now, when it comes to Oric and the Oric 1, which was the most popular of these computers, if you've never heard of it, I wouldn't be surprised, at least here in North America. These things really were trying to compete with the ZX Spectrum, and they didn't really succeed. I mean, they sold a lot of them, and there were a lot of clones, but I think compared to the ZX, they sold in very small numbers. It was made by Tangerine Computer Systems, came out in 1982, but was discontinued soon after 1984. I guess they sold about 210,000 at least in 1983, so probably more over the entire lifetime of the machine. 6502, 1 megahertz, 16K of RAM, or 48K, I think, to compete with the ZX Spectrum again, which could have either of those amounts of RAM. 40 by 28 characters, 240 by 200 graphics, 8 colors. So again, just like the ZX Spectrum, it used a custom ASIC, that HSC 10017 ULA. So that's going to be probably handling the graphics and memory and who knows whatever else, some high level of integration. And I think that's kind of like that chip we saw in here. In fact, it says HCS on this one, and on the article it says HSC. The Atmos, which was the follow-up to the Oric 1, I think was largely exactly the same machine. It just had 64K of RAM, but only 48K was available, and I think it added extended basic 1.1, so some additional features. Otherwise, it was essentially identical. Well, and it had a better keyboard, because you can see that this thing has actual keys, while the Oric 1 has these really small little chiclet type keys. It says the Oric Atmos had RGB output, which maybe confirms that this thing probably has that as well. Looks like this machine suffers from color clash, so that means that the games that are on this are probably going to be ports for the most part from the ZX Spectrum. I wouldn't be surprised, even though architecturally it's different. I think the way the graphics work are similar enough that it's probably where the games originated from. Basic seems to be a bit more fancy in that it actually has some commands for sound. Ping, shoot, explode, zap, and you can do music right from Basic. That's pretty nifty. Looks like the original Oric Atmos has an expansion port that this does not seem to have, because this has just the printer and serial port. And it looks like the actual Atmos was licensed for legit cloning. So in the old Yugoslavia, there was the Nova 64 and the Oric Nova 64. And then we have the Bulgarian Pravetz 8D, which is what we have here, manufactured between 85 and 91. This machine is entirely hardware and software compatible with the Oric Atmos. I guess that means that the RGB pinout is going to be the same, I assume, along with the parallel and serial pinouts. The biggest change on the hardware side is the larger white case that hosts a comfortable mechanical keyboard and an integrated power supply. Well, indeed, it is cherry switches, which we saw, so I guess you could say that this is a comfortable keyboard. Basic ROM was patched to support Western European and Cyrillic alphabet, with the uppercase character set producing Western European characters and lowercase giving you Cyrillic letters. It says a DIS2 compatible interface and custom DOS 8D was created. All right, well, that gives us a good lay of the land. I have a feeling powering this thing up is going to be pretty easy, because while I can't use this power supply directly, well, I guess I can with a step-up transformer. There's really no need to. We have a 7805 voltage regulator. I can usually just feed like 7 or 8 volts right into these capacitors, just bypassing the transformer, powering up the regulator, which would just give 5 volts to the entire motherboard. And judging by the way this looks, unless something like the ULA is damaged, I have a feeling this thing is just going to work. I've actually never seen a clone 6502. This is my first time with this CM630, but if this chip is bad for some reason, I can just swap that out, and it's even in a socket. One other potential issue is, I suppose, these ROMs, they may not be dumped. I could probably just use Oric Atmos ROMs in here, and that would just work as well. We just wouldn't get the Cyrillic functionality of this machine anymore, but I can't read Cyrillic anyway, so that doesn't necessarily matter. So first I did a quick search for the Oric one just to look for the RGB connector, and there's the pinout, so that's excellent. But next I noticed that, well, the connectors on the back of the board look identical to this, with the printer port being this smaller one, the Centronics, and what is labeled with a modem or a phone icon on the case actually being the bus expansion port. So that explains how you hook up the floppy drive interface to this, which would have been the same as the floppy drive interface for the Oric Atmos. Next up is a 7-pin DIN for cassette output, and we have tape out, tape in, sound, which says here you can make a lead to plug into your hi-fi for great sound. And there's the pin out for the expansion port, and it looks like we have a ROM disable pin, which means a lot like the 64 with the max mode, disable the onboard ROMs to replace them, to do upgrades with things plugged in the back. But I did read something also about being able to access all of the 64K of RAM that's on these later machines by disabling the onboard ROMs. And maybe there's some other signaling you do there that would then give you access directly to that upper 16K of RAM. That's pretty awesome. Now I found this webpage talking about the RGB output, because I was trying to figure out if it's TTL output or not. And it looks like this is a little tiny bit of a schematic that's coming from the Oric. So this is the output. It's odd that they're showing this IC sitting on the right of the connector, but it looks like this thing is buffered, because I can see a chip on here. It's not something I can read because it's one of the clone parts. But it looks like it's a 74LS365, which is just simply a buffer IC, and it goes through 220 ohm resistors. Now that insinuates the intent of the designer would be to be able to drive these signals directly with TTL logic levels. Anyhow, I have everything I need to know when it comes to the RGB output, and let me get set up with the bench power supply so we can power this thing up directly and see if it has signs of life. So I'm just trying to figure out how to hook up my bench power supply to this computer. Now, typically when you have a voltage regulator, just imagine it's a 7805, you have some capacitors that filter the voltage that's coming out of this little power supply section. So the transformer lowers the mains voltage down to something like, say, 10 volts AC. Bridge rectifier converts that into an AC waveform, but it's all very bouncy. So you got to feed that through a capacitor, and that's, say, 15 volts or 10 volts or whatever it is, goes into a 7805. The ground side of these capacitors is hooked up to the ground side of the motherboard, and then the positive side is regulated down to the 5 volts that this thing needs. Now we take a look at these wires that are going to the motherboard. We can assume that the red wire is the positive wire, and on this 74LS chip here, positive pin is always going to be this one, and we look at this red wire, absolutely that is the positive pin. If we take a look at the ground input for this IC, it's going to be found on the blue wire, so that makes sense. So this is the ground, that's the plus 5 volts that goes to all the chips on the motherboard. It doesn't have any other voltage rails besides just 5 volts. Now here's where things get strange. Typically the 5 volts is going to be coming out of this regulator, so it's going to be hooked up this wire up to the output of this, which is typically this pin closest to me. And this side is the input, which is coming from this whole circuit here, this higher voltage that's been filtered by these caps. But I don't think that's actually what's going on, because if I take a look at the positive lead, I can find that on the positive side of these caps. It's hard to read the silkscreen markings, but the pin that is closest to the back of the computer is the positive lead. Well, we have a direct connection to the positive lead going to the motherboard on both of these caps. These caps are in parallel, both of them. So this is strange. It just implies that this positive lead, which we know is the positive lead, is going to the VCC pin on this 74LS logic chip. Well, it seems to be hooked up directly to the unregulated side of this power supply. And if we go to this, what we know is the ground wire, and we go to what is the ground pin on these caps, well, it's not there. And if we go to the regulator, well, there it is on the output side. So this kind of tells us that I don't think this is 7805, or I just don't really understand the way this power supply is designed. And duh, I should have looked closer at the part number. It's a 7905, which is typically used for negative voltage rails. So I have to admit, I've never come across a power supply that's using a negative voltage regulator for something that's creating a positive 5-volt rail. So I don't particularly trust what's happening here, so I'm actually going to desolder these leads and remove this power supply from this machine entirely, and we're going to go with something else. There's the power supply removed. Now I'm going to keep this PCB because it's got this power switch mounted onto it, and I want to reuse that since that fits through the case properly. So even though this has a really cool looking Bulgarian transformer on it, I'm going to remove all these components that are on this board so I can remount the PCB, and then I can just stick a little switch mode power supply on top of it, and then I can connect the mains input that comes from this power cord back into that new switch mode power supply, and then I'll just feed the 5 volts back into the motherboard from that power supply. But of course, now with that power supply out of there, I can just feed the 5 volts directly into the motherboard so we can do some testing. Oh, incidentally, by the way, this chip here, HCS10017, well, it turns out that I found a picture of the Oric 1 motherboard, and there's that same exact chip, the HCS10017. So this is a typo on Wikipedia where it says HSC10017. Oscilloscope is set up. We're at 5 milliseconds per division on the horizontal, so we should be able to see the sync signals, and we're at 1 volt per division on the vertical, so that's perfect for TTL video signals. I have the bench power supply set for 5 volts at 700 milliamps. Let's see if that turns this computer on in 3, 2, 1. Okay, we're at 600 milliamps current draw. Definitely getting some kind of output. Let's see if we can find the sync pin. All right, and we've changed this to 100 microseconds per division, and that definitely is the sync signal. So we're looking at horizontal sync pulses, and the occasional low pulse you're seeing is the vertical sync pulse. So that's excellent. And let's look at one of the video pins if I can find one. That's got to be a video pin there. This is, I think, the blue pin, pin number 2. And well, there should be some text on screen, and maybe what we're looking at there is vertical blanking. That's why it's not down. But I think on the Oric, when you power it up, you mostly get a gray background, a lot like the ZX Spectrum with a black border around the edge, and then you get a little bit of text on screen. And it must not beep when you first power it up, because we certainly didn't hear a beep. But the fact that we're seeing a sync signal is excellent. But what we can do is take a look at some of the signals on the 6502. And that looks like pretty normal activity. I assume that's just sort of an idle doing stuff. Yep, looks fine. Yeah, these are all just normal signals you'd expect to see on a CPU. So I have no reason to believe this computer's not working right now. I think it's probably working fine. So what I need to do next is make up a video cable so we can see that glorious 8-color RGB video signal. All right, it's the next day, and you can see that I've done lots. No actual testing of the system. We still have that to do. But I went ahead and I reworked the power supply. I removed the transformer, heatsink, and all of the components from the main board. And then I used a 1 amp 5 volt DC switch mode power supply, which is basically just an old USB power supply. There's the USB jack. Gone ahead and wired that into the 5 volt output. So when I know that the computer actually works, then we can reconnect these 2 wires to the output on this board, and that should be able to run this power supply. I happen to know from the bench power supply that this machine, the motherboard only uses about 600 milliamps, so this 5 volt DC power supply should be fine. The original power cord is reconnected. It goes through these fuses to the switch and then to the power supply, so we still are actually fused, even though this little power supply does have a little fusible resistor inside. Now this was an Amazon power supply, so I have reason to believe this was actually decent quality. It's not just some junk one, so it should be able to power up the motherboard without any issue. That brings us to the RGB cable, which I went ahead and made according to the schematics, or at least the pinout that I found on that webpage. I ended up using TTL RGB because I'm going to use the RGB to HDMI for the output of this computer. Because this doesn't have the intensity bit, if you hook it up to a CGA monitor, well, it's not going to work super great. Also, the sync output is composite sync, and I ended up hooking that up to the horizontal sync line on this. For the RGB HDMI, that's no problem, and also for one of my 1084s, that's no problem. That monitor does have the capability of accepting a composite sync input on either of the sync input pins, so that's why I have this wired up to the horizontal sync on the 9-pin. Therefore, it should work on the actual monitor, but the RGB HDMI doesn't really matter. If you're wondering why I don't have the little hood installed on here, it's simply because I don't have any more left. I have to order some. And theoretically, this plugged into here goes to the RGB to HDMI. And once we power up this motherboard, of course, just hooking up the bench power supply to these wires, then theoretically, we should see if the system is actually working. I see the RGB HDMI already has an Oric profile. Let's just try that one out since this machine is supposed to be 100% compatible. Okay, so bench power supply is connected up. Let's just see what happens. We're at 700 millivolts, 5 volts, 3, 2, 1. Aha. Oh, hey, it works. It freaking works. Whoa, I saw that flashing and I was worried for a second that that didn't look right, but there we go. That looks rock solid and awesome. But we have to imagine here that this is saying that we have 37K or so abouts free, and that's probably ready, just written in Cyrillic. Well, since this is working with the linear bench supply, I think the next thing to do is I just need to reconnect these wires to the board and get this screwed back into place. We can see if this little power supply that I've installed can actually run this entire computer. 5-volt lines are reconnected to this board, and I've put a couple fasteners in there to hold it in place. Let's just double check that we have from ground to the negative rail on this cap. And then from the positive rail, that's good continuity as well. I haven't switched out the outlet on here. I'll just cut the cord and put a new North American outlet. But for now, we'll just use one of these depth adapters. Actually, this one doesn't seem too terrible. This actually makes a good solid connection into here. So first I'm going to turn on the power strip that is powering this computer. Okay, no sparks or anything like that. The mains switch is off. Of course, it's dangerous because that's now 120 volts. So we'll turn this on. There we go. It freaking works. Now, one thing that's cool about this, and it is live right now, so I need to not touch the high voltage areas, is that this is actually a multi-voltage power supply, since it's just a typical modern switch mode power supply. So I'd say that's actually improved this computer. Let's check the output voltage of this under load. 5.1. I happen to know it's 5.08 or something like that when it's not under load, but that's good. That means it's maintaining the good 5 volts, even with that 600 milliamps or so of load that this motherboard draws. If we switch over to AC mode and we take a look at the ripple, 0.0027 volts, not too bad. So one thing I'm super curious about is there's a button on the bottom of the computer, which I thought maybe is a reset button. I'm going to push it. Oh, yeah. Actually seems a bit more like a non-maskable interrupt than a normal reset. Let's try out the keyboard. I have it reconnected, just making sure it clears the power supply. Yeah, there's no issues there. The new stuff is a lot lower profile than the original power supply transformer thing that was in there. Does the keyboard work? Does indeed. Looks like we don't boot up into Cyrillic mode. Seems like we're using Western characters. I didn't actually push anything. Let's see if this works as normal. The keyboard is working just fine, which I suppose makes sense since we know it's those cherry switches. So like semicolon is up at the top corner of the keyboard. That's a little unusual. Go to 10. There's a key click that's coming out of the speaker, so we know that the amplification is working. There it goes. There it goes. I wonder what that thing at the top corner says, rat, with an exclamation point. That's obviously not what that means, but that's kind of funny. Control C. Oh, okay, so the MK key is the control key. Ooh. Do you hear that? The beep sound like fades away. Zap. These are one of the basic sounds I saw on Wikipedia. Other commands were ping. Oh, that's just the regular beep sound, which you get from a control G. We have shoot. Oh, that's really fun. And explode. Uses the noise channel. Also, what's kind of cool is notice when I hit enter, the explosion sound, it finishes after we're already back at the ready prompt. Neat. So let's try the CL key. So that's normal. Now we're getting Cyrillic characters. This is the CL key down in the bottom corner, which I think is the caps lock key on a normal Oric machine. Okay, this is a weird mode that I somehow got us into. When I type, we have 2 letters at the same time. I'm not sure what I pushed to even get that to come up. So I'll hit reset. Are we out of that mode? Yes, we are. It looks like the paper command sets the background color. Yes, it does. And then there's an ink command that sets the foreground color. Looks like it does it on all the text together. So hopefully I didn't get the RGB signals mixed up. So even if they were mixed up, the white would look good and the black would look good, but we wouldn't know for sure if the rest were bad or not. Looks like 7 is not a valid color. Yes, it is actually. I don't know why I didn't take it. So 7 is white. There should be no 8 unless it rolls around. No, it doesn't. And 0 is probably black. So with Ink 7 Paper 0, you can reverse the screen to have it more like other 8-bit computers, like the Apple II, for instance. Okay, I typed in a little program from the basic programming manual for the Oric, and this should print out all of the extended characters this thing supports. And remember, the font is redefinable on this computer as well. So there we are, some semi-low-res type characters that you could build basic games out of. And it looks like those last ones aren't even defined, which is why they're kind of garbagey looking. Okay, I typed in this little program, which should draw some stuff on the screen if I've typed it in correctly. One thing that's difficult on this keyboard is it feels pretty nice to type on, to be honest, but the layout is kind of unusual for typing in basic programs. The asterisk, colon, equal sign, minus sign, plus, semicolon, that's all sort of like up in the top corner here. Delete key is down here. It's all a bit awkward to use. You would obviously get very used to that, but right now it's, well, it's not super easy to use. Okay, so it's drawing a circle with colors. Now this computer has a high-res mode available. Oh, it's interesting. So we have 4 or 3 lines of text at the bottom. Yeah, just 3 lines of text. Kind of different than the Apple II, which was 4 lines. Okay, I typed in another little program, which should draw some lines on screen, I think. Okay. Yeah, very much like these patterns you saw on things like the Apple II. Too bad it's not using any of the color, which I know this thing can do, although it can't draw solid lines of color because there's, I think, color defined per cell. It's my assumption here that it's going to use the foreground background colors that you have set in text mode. Oh, no, it doesn't. Huh. Because obviously we have green text at the bottom, and yet the high-res graphics is still in white and black. Oh, but the paper command did change the background color of the graphics screen. But the ink command, oh, ink command works as well. Okay, so it looks like after you have the high-res command, that is where the ink and the paper commands actually do something. So now if we run this, there we go. That's just horrible looking. Let me fix that. Okay, so I just changed the program here that it picks a random color as it's drawing the lines, and the background stays as blue. So we're just kind of showing off the colors of the Oric one. I mean, the Pravetz 8D. One thing that's interesting about this program running is it looks like it's actually having to change memory when you change the color. See how it sort of does the color change and you see it scanning? It's not changing a color palette or some other register that's changing the color as a whole. It's actually writing to all of memory. And I think that's because, well, even though it looks like we're only allowed to have one color for the entire high-res graphics mode, as you can see with screenshots for games where we have, you know, sections of color around the screen, so it's not just black and white. It seems to be a lot like the attribute color situation on the ZX Spectrum. Right, so this computer appears to be working just fine. The keyboard is working perfectly. The computer itself is in good shape. I am curious how hot this little power supply has gotten, because it's been on for a while. You know what? Just barely warm. I think the fact that the end cap is missing actually allows the heat just to come out of there and dissipate, so this thing doesn't get nearly as hot as it did when it was actually enclosed like it originally was. So a question I'm going to pose to everyone watching is, do you think I should remove these ROMs for the Pravetz and put the original Oric ROMs back in? The motherboard itself looks to be basically identical to the original Oric machines, so I'm pretty sure the ROMs are just going to work if I swap them out. And because we know this has redefinable characters, that should give me lowercase and, well, all English language messages. Though the basic that's on here seems to be fully functional, it's just that some of the status messages that we saw on screen are in Cyrillic. Now, I'm reading through the manual a little bit, and here's something that's actually kind of interesting. And I tested this, and it seems to kind of work. You can actually switch this into a 60 hertz mode. So it seems that that is controllable via the ROM. So there might be some US versions of the Oric ROM that would run in NTSC mode all the time. I don't think the Oric one was ever actually sold in the United States, but maybe I'm wrong about that. So the Pravetz 8D is hooked up to the Commodore 1084 and it's working perfectly. And just like I suspected, that's turned the contrast up a little bit to make it nice and bright. So the camera, while it's capturing at 60 frames per second, the shutter speed is actually 1/50th, so it shouldn't be rolling. But I'm going to try to change it to 60 hertz mode, which should be Escape X. And yes, there it is with a little adjustment on the camera. It's now running, well, non-flickery 60 hertz mode. Now, one of the issues is, well, there's a lot more lines of text than you normally have on NTSC. I think it's 28 lines, something like that. So I got to squish the image with the potentiometer on the back of the screen, but, well, now we're seeing the entire image. So there's that little rat thing on the top, and everything looks really good. And since we're in RGB, we still have full color. And it's just a whole lot less flickery than it is when it's in 50 hertz mode, at least to my eyes. Since I am not used to that 50 hertz flicker, 60 hertz just looks a whole lot better. Now, if we type high res, it's actually going to go back into 50 hertz mode, which it just did. And if I push escape and the bracket key, there we go. Now we're in 60 hertz mode while in graphics mode. Now, if I do switch back to low res mode, it's going to go back into PAL mode, which it just did. So we can switch into NTSC just like that. And well, it's not really NTSC since there's no NTSC color. We're in RGB mode, but it is 60 hertz. Well, with that, that's going to be it for this video on the Pravetz 8D, an Oric Atmos clone from Bulgaria. And of course, this thing was super reliable and just worked right out of the gate, which doesn't surprise me because, I mean, just look at how clean this thing is. It's absolutely brand new. I feel that I improved this computer by installing the multi-voltage power supply in it, so it'll work anywhere in the world on pretty much any voltage, which I think is a nice improvement. Plus, it runs a lot cooler. Now, I know I didn't run any commercial software on this machine in this video because I'm not really sure if the machine is fully compatible with the Oric One or the Oric Atmos. The basics certainly seems a little bit different. The commands are all the same, obviously, but the Cyrillic stuff that we see on the screen, along with that status line on the top, that all seems a little bit different than the way the actual Oric is. Not to mention the amount of free memory that it showed when you turn this on is different than what you get on the Oric. So I'm assuming there's some extra routines going on this thing to add this Cyrillic compatibility that potentially make games incompatible. Not really too sure about that. So if you happen to know about that, definitely comment down below. Now, I have to imagine there's no one watching this video who ever used one of these back in the day, but, well, maybe actually. And if that's the case, definitely comment down below. I'd love to know the context of where you were using one of these. What's more likely is there's going to be people watching who did use an Oric One or an Oric Atmos from the UK or potentially France, and I'd love to hear about your experiences with what it was like having the machine that was kind of the not quite as good or popular as a ZX Spectrum or any of the other machines that were out there. And I'd love to hear why you ended up with one of these back in the day when you were a kid and not a ZX Spectrum or a 64 or VIC-20 or one of the other computers that were more popular. Yeah, I'd love to hear all about that. If it turns out this machine with the ROMs that are in here are fully compatible with the Oric One and the Atmos, then I can try building up a cassette interface cable and loading some commercial software from my phone. If, of course, a converter is available to take the tape files and turn those into WAV files, which I can play. Otherwise, I suppose it's possible I could try swapping out the ROMs on here, which surely would make this thing fully Oric compatible. But at that point, well, that takes away some of the cool factor of this thing because I do love the Cyrillic characters on the keys, and I like the weird basic that's running with the Cyrillic status line and all that kind of stuff. But I'll make a decision on where to go next with this machine after I hear the feedback from people in the comment section. So I hope you enjoyed this video. I know it wasn't a repair, but I think it was still fun playing around with this thing. And if you did, I'd appreciate a thumbs up. Huge thanks to my supporters. Names go up the side of the screen. All the usual YouTube junk, subscribe, all that kind of stuff. And I think that's going to be it. So stay healthy, stay safe, and I'll see you next time. Bye-bye.